I think he has joined, so kindly have patience. So welcome you all. Just wait for a moment, please.
Okay, so good evening, everyone. On behalf of UIT MDO Rohtak, I warmly welcome our distinguished speaker, Mr. Shivanshu Thapliyal, sir, respected coordinator, Dr. Neha Khurana, ma'am, and all the participants to today's session of the AICT ATAL FDP on advanced computing. So today we are honored to have Mr. Shivanshu Thapliyal, sir. He is an architect and team leader in AI innovation at HL Mando Softtech India, with rich experience in AI, smart factory systems, engineering automation, and generative AI. So I welcome sir and I request to sir to please continue his session.
Thank you. Thank you for inviting. So, am I audible?
Yes, sir.
Okay, so can you put me on a presenter mode because I want to share my screen?
Sir, welcome, sir. I, being the coordinator of the program, Dr. Neha Khurana from University Institute of Engineering and Technology in Maharishi Dayanand University, Rohtak, Haryana. So I welcome you in this session and hope our participants will learn a lot from you. And for present, you can present your slides from your own side, sir.
Yes, actually, thank you,
Screen.
Professor. I got your message. And actually, when I'm presenting my screen, it is saying that the presenter need to, somebody else is the presenter right now, so I need to be the.
भव्य 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 आप प्रेजेंट करना बंद करें भव्य.
यस मैम मैंने बंद कर दिया प्रेजेंट करना.
Yes, and now you share your screen, sir.
Okay, just give
Okay,
me a
sir. Okay.
second. Hello, Bhavya. I'm using my
Yes, sir.
laptop and it is saying that I cannot share my screen. Okay, I'll do one more thing.
Sir, you can try rejoining the meet.
Sure. I'll rejoin.
भव्य क्या हुआ?
मैम सर प्रेजेंट कर रहे हैं अब तक, शायद स्टार्ट नहीं किया सर ने।
Hello. Yeah. ये नहीं है, इसको बंद करो। Okay. Hello, Bhavya. I'm facing some IT issue. Give me 2 to 5 minutes. I'm just resolving it and share my screen. Just issue is the sharing screen.
ओके सर, नो प्रॉब्लम सर।
There is some security concern. Just wait for a minute.
ओके सर।
Sir, what you can do is you can share your slides to Bhavya and he will share his screen. You just share your slides to Bhavya. Jagriti, call up sir and ask him to share his slides.
Okay, ma'am. Okay.
है ना? Share his slides to Bhavya and he will this share his screen, okay?
Actually,
Sure,
ma'am,
ma'am. Okay.
Then
document
you
is
may
also
speak and
logged.
may continue.
So our IT team is working here to resolve this
हाँ,
issue.
sir,
Give us
right, sir,
5 minutes.
right. But until then, in the first few slides, na, you can do this. When the problem will be solved from your side, then you can join with your own shared screen. Jagriti, kindly do the needful.
Yes, ma'am.
Dear participants, have some patience. Actually, in this technical era, such type of issues may occur. Meanwhile, if some of the participants wants to share his or her experience in any of the work done by the participants in AI field, he or she may can. From where we have the participants.
So, dear participants, due to some minor technical issues, there will be a short pause before we proceed further. So, in the meantime, as per our institutional tradition, we shall take this opportunity to play the Kulgit of Maharishi Dayanand University, which reflects the values and vision of our university. So, I request everyone to please remain connected and enjoy the Kulgit. Thank you for your patience.
अनुसंधान से विज्ञान से हम ज्ञान को अर्जित करें। निस्वार्थ हो श्रम भाव को इस राष्ट्र को अर्पित करें। ऋषि कुल का सम्मान ही हम सबका स्वाभिमान हो। जब कोई व्यवधान हो, अनुष्ठान हो, व्याख्यान हो। संगम है कला संस्कृतियों का। संगम है कला
Hello, Neha. Can you share the presentation which I had shared to you?
Yes, sir. Just a second.
Avya, can I get the control?
Yes, sir. I have made you co-host. You can control the slides.
Okay, got it. Got it. So I think it's better I will start now. Hello? Shall I start?
Yes, sir.
Okay.
Bhavya,
Yes, ma'am.
Okay. So, okay, I'm starting. So thank you, everyone. Thank you, all the professors, for inviting us for this session. And it was our pleasure, my pleasure to be here and give some information from the industry side. So the topic which I choose is generative AI and agentic system. As we know, these days everyone is mimicking about agentic AI. So but what actually is running in the industry and what actually is happening in the industry. So we would like to share those kind of information or some knowledge. So how about redefining the future with advanced computing, because uh, when we still remember that when computer comes to this world, and then how it has reformed the existing world, and then now AI is in the world, how it is going to reform, and how each step everyone in the industry, everyone in the university is trying to approach a new format, a new something new which could have present an impact on the in this world, right? So next slide, please. Okay, so I will like to cover the content of starting from generative AI. So I believe that as the session is about the modern computing, so I believe everyone is aware about the AI, but generative AI is something which is coming from the background of the traditional AI. Then I will go with the agent generative AI, then I'll go with the agentic system and how the agentic system works. And then what is the shift, how this shift has been coming from the automation based system to the autonomous agents or agentic AI or autonomous system, right? Then we'll talk about the agentic system, where we'll brief about some general architecture and orchestration, and then what kind of applications we have. So I like to cover some real-time information as well, and real-time knowledge what we have faced, what we are doing right. Next slide, please. So generative AI is a focus on creating content. So I think everyone aware about this, and not executing task. So that's how it has been named as a Gen AI. A short form is Gen AI, and it is a foundation behind text, code, image, and media generation. And the interaction starts and end with the prompt and a response. So earlier, as we know about that traditional AI, we need to first give some particular information, and then we can get the only particular information out from that traditional AI. But generative AI behaves a little different. Here, we talk to the generative AI in form of normal human language, and it gives us the output in the form of, again, normal human language. But there is a science behind it, that how it actually converts, understand human language and go through with it and find out the information, whatever he have, and then tries to give us in the same format so that we understand. Now, let's have a brief understanding about generative AI. So the model, when we have a generative model, it interrupts the user prompt and surrounding context. And then it converts the language into mathematical representation, which is the backend it is going on. And then meaning is captured systematically, semantically, and not through the keyword matching. And then that context from the previous interaction may influence output. So that semantically, whatever happened in the backend, that is our main crux, which defines that our output is going to be how much accurate or how much validated or how much wrong. Then if we talk about the context generation, basically the model predicts the next token. So I just want to ask something that with the audience, that everyone aware about the token system in the generative system, right?
Yes, sir.
Okay. Thank you very much for the reply. So because because all the professors are there, so I believe I can talk in the technical form, not with the management things, right? So what happens is we prepare we have the next tokens, and then one step at a
Sir?
time. Hello.
Members and students also, masters and research scholars.
Okay. Thanks for the information. And then what happens is our output are constructed dynamically, not retrieved from storage. So this is the beauty of the generative AI, that it can generate text, code, and images and structured data based on the request, whatever the human is doing. And then this creativity and this consistency depending on the configuration parameter. So we have some parameters to prepare the generative AI system, basically LLM models, we say it, right? And then if we talk about the refinement, how that refinement happened in the Gen AI system. So basically what happens is our output quality depends on the heavily on prompt clarity. Prompt is very important for the LLM model. And then instruction example and construction shape behavior, that is a kind of side dish for it, right? And then feedback helps improve the result across the iterations. So whenever, as we are in the age of AI right now, and I believe everyone uses Chat GPT and this kind of other kind of products. So we just enter and it processes and give us back the result. So those kind of, high processing, that refinement happens outside the core model. So those kind of things happen, not in the model. And then finally it comes to the response. So response may be delivered all at once, or it may be streamed. So one by one it will come, or definitely it depends how the architecture we have built. And once the delivered, iteration typically ends. Actually, it is now waiting for us to continue the conversation, or it is now waiting us to start the new conversation. So finally, generative AI excels at explanation, summarization, and creation, and it serves as a powerful cognitive engine in the AI world. Next slide, please. So anyone have any question about the generative AI?
No, sir.
Okay, I'll continue. So why I thought to explain as a generative AI as an initial system, because for agentic AI, generative AI is the heart of it. It is the, it is the main core of it. Whatever system we can build on, whatever system we can rely on, But if we see generative AI will going to process our requirements, whatever, whosoever the agent can be, but it will process our requirement. So if we see that, let's first align with the agentic AI actual meaning. This is not just smarter automation, a better chatbot. Agentic AI represent AI system. I'm talking about this system level right now. So it represents the AI system that can act and with the intent and anatomy. So that kind of process it have. It is not an like that we just connected with something else and it start performing as an automation. So it is totally different. So I know so many scenarios are in the industry, in the universities or in other places. There might be a confusion then what is automation and what is AI. So we need to figure it out in depth, going in depth, and then finally decide that it is an automation and it is an AI system. So if we combine as a large language model, machine learning, and the automation, and design to operate in a real world unstructured environment, which moves beyond the predefined rules into the decision making system, and that key information and that key idea is just a response but decides what to do next. So that is an agentic AI system which have the whole environment, and it can go beyond limits whatever we have decided, because that LLM model, that generative AI model which is supporting in the back end, it has the capacity to think more. As I already said, it is not the stored data. Generative AI don't give the stored data. It is generating a new data for you as per the request what we have given. So if we go with the agentic AI system understanding, then the system, first observe the environment. It interprets like input text, data, signals, anything it can be, whatever your agentic system is designed for. And then that context matter not just happened, but why and what it means. So that is very important. So that context matter is not just happening. There is a matter of, it means why it is there, what it does mean. And this forms that system and situational awareness. So this is our understanding of agentic AI system, how it understands. And then it sets the goal. So if we, let's say, assume that we are giving some prompt to the agentic system, even though nowadays earlier ChatGPT version, and I'm just quoting the example, not doing any promotion. So if you see very first launch from the ChatGPT, it is just a conversation between a human and the LLM model. But now the current version, what we have right now, is actually an ChatGPT is an agentic system is there. So it goes, understand your requirement, and then based on the requirement, it sets the goal setting. So once the context is understood by the agent, and that system defines objective for your content, and then goal may be user defined or inferred with the situation, but large tasks are broken into the smaller ones and subtasks, and then priorities has been done. So inside the goal setting, all these options are happening, and then it is going to the execution mode. That agentic system is going to the execution mode. That system takes action into tool, API, workflows, and then there are a lot of things, right? And action happen with a minimal or non-human intervention. And there is an agentic, AI becomes operational, not advisory right now. So execution is monitored to track outcomes. So now execution also tracking, is it I'm giving good or not? If it is bad, then it goes and reverse, and some content is already approved, and then some content is again reversed and recreated and then submitted to it, and then it is coming into the learning phase where it says the results are evaluated and original goals as per the original goals, and then it will refine as per the future feedback or whatever you say, oh, this is coming wrong, and can you update this particular sentence or part, something like that. And over the time, system becomes more reliable and efficient. So this is the beauty of agentic AI, that it have the capacity to learn by itself and then suggest new agendas, new opinions after learning your current environment. So agentic AI follows a continuous loop. So if I just say very simply, and understand the plan, whatever the plan we have then had given, and then act and then learn from that plan, even though it has given the output, but it is still learning. So that kind of agentic AI architecture is nowadays industries are developing, we are developing, right? So this is all about from the agentic AI system. I think I took more time, so please stop me if I'm taking more time. Any questions so far?
Yes, sir.
Yes, please ask the question. If any question, otherwise I move forward.
Difference between generative AI and agentic AI, which you describe.
Okay, as I already mentioned the difference, so I'll try to make it more simple form. So let's say generative AI is just an LLM model which generates the which generates the content for you, right? And the agentic AI is the system, is the environment which takes the action from you, but setting the goal as per the action you had given, and divided into the plain steps, use some other different tools and make decision, and then autonomously learning from there. So this is the big difference. Generative AI cannot alone learn by itself, but agentic AI is have the capacity to learn by itself. So in very simple words, generative AI is just your answer to the question. Let's say you ask me the question, what is the difference? I just give you the answer. This is generative AI. But agentic AI is, if you say, I want to create a document which something have some points, some pointers like this, and it should have this kind of image. At that time, agentic AI is working for you, and you're getting your work done. This is a very simple, uh, analogy I can give you.
How agentic AI helps in marketing area?
Okay. So anyway, I am not from the marketing background, and whatever scenario I know so far around the marketing side. So if you have, let's say, you have some task to launch, I'm assuming it right now, right? Don't take it as a final thing because I'm not from a marketing background. So let's say you want to increase the, let's talk about the online marketing, right? So let's say you have the, you want to increase your ad or some product with the conversion of 20% or 30% in the internet, right? So currently your conversion is something, but you want to increase with 20%. So what it will do, agentic AI, what will do, if your environment is already set up with the agentic AI, your architecture is set up, then you just set your goal, increase the website or this product, what I have, this conversion by 20%. So what it will do, it will prepare an action plan, choose the channel where you want to go more site. It will suggest you email, ads, or social media, something like that. And then do you want to link this? Please input your account details. I will directly go inside and decide audience segments. It will decide the audience segments. It will pick the content strategy, what kind of content existing is there, if it is the existing product or a new product. If there is a new product, it will suggest you the new strategy. Your old strategy is this is the old new strategy. Do you want me to proceed? You can accept at that time. So it is a continuous loop, accept, reject, something like that. And then it will take action, whatever that you have given, said okay, accepted, generate the ad copies, launch the campaign, adjust the bit. So you don't have to go manually there. You are saying to your agentic system that okay, this is my problem, this is this. It will share you the action plan. You can just accept, reject, and then based on your working environment, every time it will monitor and learn and track your things, how you are doing it. And then finally it will optimize for the, let's say, it is already tracking all your ads, for example, and it will say, it will pop up to you, this your ad is not performing, this is very poor ad right now, please pause your ad. or scale the high performance one, or maybe change message per audience, something like that. So that kind of system, it will proceed the work for you. It will extract the information from the and other outside environment for you, and then it will prepare a final things for you. It works like this.
Thank you, sir. Very well explained, sir. Is there any app for agentic AI?
There are a lot of things, but what is your objective? It depends on it, that what kind of objective you want. Because one app, because as I said, that agentic system is an environment. So as of now, there is no permanent all environment feasible agentic AI system is not yet developed. But yes, if you want to say marketing side agentic AI system, might be. I'm not sure. I don't know about it. That's not my marketing is not my field. But that area you can explore, that any existing one has there, or if you are from a technical background, you can start developing from your side as well.
Okay, sir. Thank you.
Thank you.
Sir, this means that generative AI creates new content. If we say that audio, or it may be the images or the text. While as if we talk of agentic AI, it can help in taking decisions or take action using the autonomously tools. It is the AI assistance.
See, any which way, generative AI is the heart of AI agentic system. So you have to put the generative AI behind. But if we talk about AI, agentic AI, that is one, as let's say if our body, heart is performing its operation, hand is performing its operation, mind is performing its operation. So agentic is like something like that. You have full body, as a full system is there. Not just one opinion is there, just not just LLM. Generative AI is actually working as a heart for it, as a mind for it. But other kind of body parts are something else, which is like setting this environment, giving the access to your Gmail. Maybe if you want daily, what kind of important emails, let's say you want to create an agentic system for your Gmail or any university email, that how many useless emails came, and then what are the basically content in the useless email, what are the important emails, and what are the main content. You don't have to go through with the each email. It will give you a one liner, two liner, whatever you suggest to him, and then daily it will repeat for you, and then daily it will learn from your emails. It will say tomorrow he is going to have a meeting with you. Something like that it will happen.
Yes, sir. This means agentic AI takes the action and generative AI creates the content.
Right.
Okay, thank you.
Next slide, please. If any other question, then we can take. Okay, I think we can move next if there is no question. Okay. So as we understand about Gen AI and agentic AI, so let's talk about the how the rule-based automation and autonomous agentic AI has been evolved. So if you see, to understand where we are today, it helps us to see how we got there. So AI evolution has happened in clear phases. There is no disruption in between actually. And each phases increase the flexibility and intelligence. So if we see in 2000s, right, before pre-2000, that is before 2000, system was based on fixed, hard-coded rules. So in our company, we say it as a traditional AI. So we make it more general. So traditional system AI is like, hard-coded rules are there. Okay, these are my parameters. These are my temperature. For example, very simple example. These are my temperature, and I want to predict next day temperature because I have 1 year temperature data of my room, right? And then I want to predict what would be the next day temperature, and it would be, the accuracy is not 100%. That is the most behavior was predicted by rigid, because it is rigid. It cannot predict any other thing than temperature, because we trained it on a temperature data only. And any change required, manual reprogramming is required. If you want to change anything, again do the programming, again train the model, again do the check the how can I say, again check the accuracy, again check it, and again input into the system, and then work only with stable environment. If we just go talk about, oh, what is the temperature outside, it will never gonna predict, because we never trained on it, right? So that is like early AI side. And then we went to the machine learning era in 2000s, right? Their models began learning pattern from data. Improved prediction and classification task has entered, and less manual rule writing and more data dependency happened. Still, limited in reasoning and adaptability. That 2000 machine learning era is like very limited in reasoning and adaptability, because it cannot adapt until unless you cannot train again, you cannot adapt. Then, suddenly in 2010s, very deep gap, 10 almost 10 years gap, we come into the rise of LLMs, and then it becomes a capable understanding language which understand context, intent, semantics, improved significantly, and the system could handle unstructured data that you can ask about so many things right now with the LLM, and then it will give you reasoning. So those kind 2010s, actually it is about the reasoning, the interaction between more natural. So what was the best part is there, whenever you are interacting with the LLMs, it is the interaction is very natural. You can just say, I am doing like this, what could be the objective of the next thing, something like that. And then in 2020 is present right now, agentic agentic AI enters into the world, and AI system now operate with anatomy. That is very important. They can define goals, as I said, plan next steps, and act on it. So goal defining, what should we do the next steps, and then acting on it. So this is the agentic AI. Continuous decision making replace the static workflows, and human oversight shift from execution to governance. So that is a very important point happened. And then when agentic AI happened, suddenly it start with the multi-agent system. Why we have one agent? Why it is just contacting my Word file in the system? Why it cannot contact the whole Microsoft package? Why it cannot contact other application in my system? I'm taking very simple example so that I think it would be understandable at a very large scale. So multi-agent collaborate on a complex task, and some agents generate solution, other validate them. So when we design the architecture of agentic AI, we have solution generating agents, and we have validating agents who will validate the solution, it is coming good or not, it is coming right or not. And then it enables the robustness and speed and accuracy. So that's how agentic AI, is like more appropriate to stabilize your ecosystem, your bigger system, and then it acts on it, it performs on it. Otherwise, we have to do a lot of jobs, a lot of things to do, and then but agentic AI have handled so many areas in it to prepare the optimal accuracy and prepare and validate it as well. So finally, this shift makes from move from automation to anatomy, and from script system to the adaptive intelligence. So that is all about how we have shift from rule based automation to the autonomous agentic AI. So earlier, if anyone remember, we have to write some scripts. So those kind of scripts are now no longer, nobody is talking about it. Nobody is trying to put any script inside it, just trying to make, trying a system which should be adaptive and intelligent. Okay. Any questions on this slide? Okay, next slide, please. So now I would like to explain some little bit in depth how that function works. This is an overview, not any of the architecture related to our current working system. So very not in depth, but useful for learning purpose. So agentic AI is not a single agent model, as I already mentioned, right? It is a system architecture. So if we see that when you have, how can I say, it is not visible. So if we talk about the core principles, I think I cannot see it in a presentation. Core principle, anything, anyway. So it start with observe. O is observe. Next O, left side O is observe. Right side O is orient. And D is decide, and then act. So this is the core principle of the agentic AI, right? And how that ostration happened. So build around a continuous, how can I say, continuous loop that going to take the decisions, and observe, orient, decide, and repeat, act. And then feedback keeps the system aligned with the goal. If we don't have a feedback inside the system, at the time we can feel that the output which is coming right now is not validated, not sure. So that feedback system, that validation system is actually aligned inside the architecture, and it is very important because it's not just giving the question and get the answer. So there are multiple loops are running. And then if we talk about, input layer, let's say right side input layer, right? So input layer receives user request and system signal, real-time data. You can put anything, whatever your system is designed for. And then input may be structured or unstructured. That is a very beauty of this thing. And then feedback is treated as a first class signal. Whenever you give as an input, your feedback is as a first class. So every time, as I mentioned, that it is taking your approval, it is giving some system. So that system is designed such a way that it is every time asking you, is this okay? You want to proceed with this, or I have two options. You want to proceed with which options? So that kind of feedback system is there, right? And then ostration layer, there, what exactly I had explained previously, your goal breaks into executable task. It will decide whatever you have written to given the goal, it will divide and share it to the AI agent. It will plan, reflect, tool use, or self-learning loop. So it will decide after dividing or cutting your goal and breaking your goal, it will decide where to send. It need to send to the planning stage, reflection stage, or tool use. So each planning stage have own independent LLMs. You can see LLM 1, 2, 3, 4. So each stage is now generative AI. LLM 1, 2, 3, 4 is a generative AI. Separate models has been kept out, and then each agent has a specialized role. And those specialized role having agents may collaborate or compute, reflection or self-check, improve reliability, and some can plan, some reason, some execution. And then that information goes to the multi-LLM, may be used for different roles, memory system, provide long-term context. Vector database also is there. So this is a more technical, is knowledge graphs and enable retrieval. So it will store in the knowledge graph, it will retrieve, when to retrieve, when not to retrieve, it will happen like that. And then it will go to the execution and learning stage where agent interact with the tool. Let's say your agent is involved having Word document involvement, or your Chrome browser involvement. So it will go to the tool also, and then it will decide that learning improves, how can I say, it will create a result evaluated continuously, and then it delivers the output which may inside, which may be insights, action, update, and knowledge is updated for future use. And then how the governance plays a very important role here. I think in AI, governance is very important, which is safety, ethics, and compliance. So the system, whenever we design any architecture, we need to think about the safety first and the ethics. Whatever the output the model is giving, it should not get worse. It should be always aligned to the ethics. And then it should be compliant, because human remain in control of boundaries and intent. So that's why there is a feedback system also there, which human is controlling. No, you need to think in this direction. You need to generate the content for me in this direction. You need to perform the operation for me in this direction. And then finally, if we talk about the whole system, so architecture and enable anatomy. This is the architecture plus ostration, which is we said as a anatomy. And then ostration enables scale and trust. So that's how this whole agentic system works. Any questions? Might be a little bit confusing, or maybe so many questions. Okay, next slide. Okay, so finally, I think it's a last slide from my side. So applications of generative plus agentic AI. So if we see, technology matters only when it creates value, right? And this is where intelligence turns into outcomes. So if we talk about the benefits, efficiency through automation of knowledge work, and scalability without linear cost growth, and maybe adaptability of changing environment, and collaboration between humans and AI, reduce operational cost, continuous improvement over time. So these are the benefits of the generative AI plus agentic AI. And then if we see about the combined capabilities, so generative AI creates insights and content, as I already talked in my previous slides. And agentic AI turns insight into actions, right? And together they enable end-to-end workflow. That is very key for it. And if we talk about the industry applications, so autonomous system responding in real time, healthcare, maybe process intelligence and design support, and financial operation and compliance automation, and maybe customer engagement at scale. So it is a kind of some marketing point. How you going to engage your customers, right? And then if we see about the some example scenario, it will be like, uh, how can I say, intelligence health record analysis, and maybe sentiment aware conversation system. So there will be there is, I think already it exists, where based on our sentiment, conversation is happening. And if we talk about the CRM system, which contextual recommendations, every industry has the CRM system. So there, and university also, I believe they have. So their contextual recommendation is the more appropriate way to design the agentic AI. And then if we talk about the operational use, use cases, maybe real-time data analytics, supply chain optimization. We are already in our company, we are already performing in the smart factory. So we are preparing the supply chain side, we are preparing the manufacturing belt side. So those kind of things we are preparing and optimizing it with the agentic AI system. And self-healing infrastructure, maybe something like that. And if we talk about the execution pattern, so it generates understanding, it decides the next step, execute actions, and learn from outcomes. So this is the overall crux of the agentic AI, which I said, that execution pattern. So based on these 4 points, agentic AI is based on. And then the shift from the insight to impact, and from AI tools to intelligence system, that is the main part of it. Yeah, I think I am done from my side. Any questions? Next slide. Yeah, I think I'm done from my side.
So thank you so much, sir, for such an insightful and enriching session. We sincerely appreciate you for sharing your valuable time, knowledge, and expertise with us. So
Thank
before we proceed further, I would like to inform all the respected participants that the feedback form for the session has been shared in the WhatsApp group. So kindly ensure that you fill the feedback form as attendance for today's session will be marked based on the submission of this form.
Okay, I think Jagriti, all done from my side, right?
Yes, sir.
Okay. Thank you, Jagriti. Thank you,
Thank you,
Neha.
sir.
Thank you, Bhavya.
Thank you, sir.
Hello.
Yes, sir.
Yeah.
Yes, sir.
Very good afternoon to all.
Good afternoon, sir.
Okay. I hope my screen is visible to all of you.
Yes, sir.
I'm sorry, actually, in our organization there are many security features are there. So basically, Google Meet we are not able to share a screen. Okay. So I'm using my personal laptop.
No problem, sir.
Yeah.
So now moving ahead, it gives me great pleasure to welcome our next speaker. We are honored to have Puran sir, who brings with him more than 21 years of rich R&D experience in the automotive industry. He has worked with leading organizations such as Maruti Suzuki, Suzuki Motor Corporation Japan, and Mahindra. So I now invite Puran sir to kindly take over the session.
Okay. Thank you, Jagriti, and thank you to all organizing committee for organizing such a wonderful session. So I think introduction you already have. So I'll start my session on cybersecurity solutions for sustainability mobility. So in protecting modern transport through advanced digital defense. So, just one minute. So there are 5 areas which I'll cover. Okay. So first I'll start with the car technology journey. For example, this is I think a very interesting topic. You may enjoy it. So basically, I'll touch upon the what are the evolution is there from like mechanical system to software defined vehicles, and since there are lots of electronification is there, so definitely there are the threat and challenges. So what kind of threats are there in terms of cyber security? So that I'll cover in second part. Then I'll just briefly discuss about safety versus security concept. Then in automotive sector, what are the cyber security features are there? What are the potential touch points? And what kind of regulations which we have? That part I'll cover. And there are some approval processes are there which are related to cyber security management system, which will be covered in this session. And after that, in vehicle, how we are implementing cybersecurity. So I'll cover a few glimpses of that. So first, let's start with the car technology. Okay. So I think you might have heard about basically when we talk about automotive. So we think it's only a mechanical branch, right? So most of the people think like it's a mechanical branch only. So it is for the mechanical engineers, but this is a myth actually. So if I talk about in car technology only, so usually if you can see here, for example, there is a steam engine that was invented in 1769. Then later on in 19th century, like 1886, there was a gasoline engine, that is a petrol engine. So then thereafter, if I talk about till 19th century, it was mainly up to gasoline or petrol or diesel engine only. But when we move to 20th century, so definitely now the time of autonomous vehicles, like you might have heard about driverless cars. So this evolution is from like till 19th century to 20th century onwards. There's a huge changes in automotive industry. So in this, it's not only mechanical engineer which have the role. It's like even electrical engineer, electronic engineer, computer science engineer, or even the civil engineer also have lots of opportunity in automotive sector. And every branch has a role in designing and development of different components in automotive sector. So I just want to clarify, like it is not only mechanical, but it's a combination of all branches which can adapt like automotive industry. Okay, so that is one part. So I'll cover like, okay, this is the powertrain. Powertrain basically, I think you might be knowing about it. basically which gives the energy to the vehicle. So in till 19th century, we have steam engines, we have a carburetor type of engines like this. That was the era of 19th century till. But 20th century onwards, there is a different electronification in powertrain system. Like we have a controllers, like which is like ECU. This is the EMS, like engine management system, where we have a sensors which give the inputs to the controller, and we have actuators which actuate basically in engine side also. Like there are many actuators which are working. So it gets the input from sensor, and ECU process it, and based on that there is a actuation. So there is a completely electronification in the vehicle in powertrain. So first there was a gasoline or petrol engine, then there is like a hybrid engines are there, which is combination of gasoline, I mean petrol, as well as the electrical vehicle. And there is a fully electrical vehicle evolution. So now you might have seen many vehicles which are EV, so that are fully powered by the battery. And also parallelly there are fuel cell technologies also there. So main purpose is like in powertrain there is a huge evolution, and there is a electronification in powertrain systems. So similarly in braking system also, you have like previously, I mean, if I talk about, I mean, very old systems which are there are were the wooden brakes which were being applied. Then there comes to the like a mechanical drum braking system, then hydraulic braking was in picture. But nowadays there is a completely electronification. Like in braking, there is a completely electronification, and there is a ABS system, there is a ESC system, and even there is a autonomous emergency braking. If you see downside, there is a autonomous emergency braking which is there in Mercedes also. So what it does is it like automatically does the braking. For example, it detects the object in front of it, and if driver is not able to brake, but don't worry, if not driver, then definitely automatically this will get braked by the system. So that is the AAB. Similarly, there is a ABS system. So now in braking system itself, there is a completely electronification in the vehicle. So after 20th century, that is the main objective. Similarly, if I talk about transmission and air conditioning also, you might have seen the manual transmission, like there is a gear system, and you might have seen the previous old vehicles have manual AC. But nowadays transmission is also completely automatic, and there is a AC system also automatic. So how it works, basically again there is a transfer transmission control module which gets different signals from different areas, like engine speed or even the transmission inputs from driver. Then it actuates the transmission accordingly. Similarly, in auto AC system also, similar concepts are there. Like it gets different inputs like humidity sensor inputs, some multiple cabin temperature inputs, external temperature inputs, then what user is selecting, that temperature even settings. So all these inputs are being processed by the MCU, that is the climate control module, and then accordingly it like drive air conditioning unit and even the actuators which are there in flip control. So in this also, like in transmission as well as in air conditioning, there is a completely electronification is there. So now you can realize like even every system in the vehicle has the electronic devices, electronic uh, controls. So now, as I said, that the myth of like in automotive only mechanical engineers are working is completely wrong. But now the true picture is like every engineer has a role in automotive sector, and there is a huge potential career opportunity for every engineer, like electronics engineer or computer science engineers, or even mechanical as well as even IT. So every field has a computer, even leather technology people or some other in engineering area, for example, for designing part, they are working like seats material design or interior material designing, uh, selected by chemical engineers. So every field has a role in the automotive sector. So that is the main objective which I want to emphasize. Second part is like, if I talk about, as I told you, like there is a car technology journey, there is a evolution. So in first phase, you can see there is a mechanical engineer area, like it's a era of 1980 to 90s of mechanical era. Then 2000 onwards, it slowly and slowly comes to the electronic part. First, it started with the engine, slowly and slowly for others also it started. And in now, like 2020 onwards, there is a software defined vehicles, which we call SDV. Okay. And there is electrical vehicle, and there is many connected cloud native vehicles which are driven by AI. So that is a complete evolution of vehicles technology. So if I talk about key standard like cars, for example, previously in even in 2010 to 20 also, like there were the even mid-size vehicle also have average ECUs of only sorry, high segment vehicles also average ECU quantity was 15 to 20. But nowadays, like in this quantity has raised in huge quantity. So basically now in a premium car, luxury car, you will find almost more than 100 ECUs in the vehicle. So every function, damping, even suspension, every function is being controlled by ECU. So that is the, I mean, evolution in the vehicle. So if I talk about key ECU makers, we have HL Mendo, which we are working on different controllers. Bosch is there, Continental, Denso is there, Delphi technology are there. And in case of automotive itself, there is a huge scope of research as well. And there is also need of cybersecurity in automotive sector. So now we have covered almost the technology transfer, for example, from mechanical side to software driven SDV. So now with technology, definitely there are the challenges. So what are the challenges? Basically, of course, there is a threats like which for the connected vehicles, like major threats which we have. There are some physical threats, some unintentional damage, and some malicious actions are there, on failures, malfunctions are there in the hardware or software. There are some outages in terms of a network or cloud, and there are some, for example, interceptions are there, and there are many unauthorized activities and legal regulatory threats are also there. So I'll just show you some of videos, okay, where you can see that. Just one moment, wait a moment. I don't know whether you will be able to. mm, Sound is audible to you?
No, sir.
Video
No,
sound?
sir.
So now you can see that all safety mechanisms we had. So auto drive was activated. Now somebody else is controlling the vehicles. So actually, this is a movie, but actually in realization also this can happen anytime if there is no cybersecurity in place. So almost every car you can see they had control, had the complete car. They put in driving mode. So this is how dangerous it is. Like we call it automotive sector. We have a just 1 minute. Sorry. I'll show you another video. Basically, you might have seen many, for example, news also like hackers remotely kill the jeep on highway with the me in it. And similarly, if I'll just, I think there is wait a moment. Okay, I'll show you another video. So here also you can, this is a true video. Basically, car theft is there. So they had already, there is a system, okay? Like they had hacked the keyless entry system. Okay. So what it has done is they has some range extender. So it has activated that range extender. Then there is a thief. So it is a complete access. Similarly, okay. Okay, so main objective of this showing is showing this presentation is basically we have a huge potential of hacking. One side we have seen like there is okay, there is a, for example, electronification in the vehicle side, but definitely parallelly there are many challenges. So that is the main challenge is the cyber security. So I'll discuss uh, briefly about what is safety and what is the security. Okay, so safety is mainly related to hazard, and security is mainly related to the threat. So what is the security? So basically, security deals with the protection against the threat which are originated by humans. Okay. So basically, threats are originated by humans, security side. If I talk about safety, the safety deal with the protection against the hazard risk by operation of the system. For example, like inside the system, there are inputs and outputs. So if and processing is there. So out of these three components, for example, inputs, processing, and output, any component has some malfunctioning, so that is called a safety concern, or that is a safety hazards. So these can be mainly by maybe people as well as the environment. But if I talk about security, security is only related to the people or hijacker. Okay, so that is the main difference between safety and security. Then what are the characteristics of safety and security? So security, basically, as I told you, this is a protection resilience against the unintentional attacks, okay, including accident or hazards on the confidentiality or integrity and availability of the information. Okay. But if I talk about safety side is unintended. If you talk about security, it is the intentional. Okay, so that is the one character, and it is on confidentiality and integrated availability. But here it is unintended failures, okay, which have the hazard to life or the physical conditions. Okay, so that is the main characteristic point of view difference between security and safety. And in case of system which have a cyber security features, always consider the potential threats of the attack whose main goal is to harm or cause some destruction or gain some financial or other benefits, or simply to be get famous. And what in safe security, what we need to do is identify the weakness, continuously adoption of system to defend these kind of threats during or after development at the end of support. So each phase we need to identify each area where we feel like these are the new threats, and accordingly we need to develop the features inside the vehicle, security features. Similarly, if I talk about safety point of view, safety also we need to, like, there is a what safety is basically introducing some error must be avoided, and introduced error must be found early in the life cycle. If here we talk about security, this is in development phase as well as the after mass production, but it is which must be in safety point of view, it must be identified early in the life phase, like development phase only. Okay, and errors in operation must be handled in safe manner. So that is the characteristics which safety deals with. And other side I have discussed about the security characteristics. So what is a convergence? So basically now we have identified what is a security, what is a safety, and what are the characteristics. And now talk about the convergence. Okay, now we have identified the weak area. Now we need to deal with these weak area. So in automotive sector, what they have done is, like, we have a functional safety. The left side is completely safety related regulations. So we have defined the function safety regulations, where inside the regulation itself, like this ISO 26262 is there. So here we need to think about what are the hazardous analysis we need to do. We need to design some fail-safe mechanisms for safety critical functions. Okay. Similarly, in security side, mainly it is related to cyber security. So we have a regulation ISO 21434, which clearly define the framework how we need to define design securely. What are the threat modeling? What are the we need to assess the each risk, and there is a hardware security module or key management system HSM and KMS, cloud security for automotive system, which we need to introduce in line to this ISO standard. So left side first we deal with some functional safety, other side is the cyber security requirements. And there are some overlap areas where, because we need to integrate the complete system, So there is a safety and security both has to be taken care, and this is a joint process where it is the coordinated requirements related to security, requirement related to safety, then combined testing is there. So testing related to safety, testing related to security in the vehicle, and there are some governance and complete sync between these two teams. So function safety team and cybersecurity team, both teams has to be in sync so that at least whatever system, or for example, if I'm developing some component like ABS system or some other controller, so inside controller, I need to take care about function safety as well as the cyber security. So in cyber security, what are the touch points are there? Okay. So there are potential attack surfaces. We call it touch points where I think there is a threat or there is a probability which can be hacked. So because in connected vehicle we are like vehicle is connected to cloud also, vehicle is connected to mobile communication also, satellite communication also. So communication network itself is like it can be unsecure.
Excuse me, sir.
Yeah,
So please maximize the slides.
it is not maximized.
No, sir.
Sorry. Now fine.
Yes, sir.
Okay.
So still that Google, yeah, this one,
Actually,
this one.
I'm not able to. I'm trying to do it. No, no. Wait a moment. Usually we don't use Google Meet. Okay, so I'm not too much aware of. Wait a moment. Let me try again. No, fine.
Yes, sir.
Okay.
Yes, sir.
Still you have that window, Meet.
No, sir.
Okay, great. But I have now. Anyway, so I'm covering about the what are the touch points which are potential attack surfaces are there. So network itself is one touch point where there can be the possibility of cyber security threats. And similarly, inside the vehicle, for example, outside vehicle also, there are many touch points, and there are the like there are many security features, some mobile communication, some fleet management system which are integrated with the vehicle communication. So almost everywhere you will find the touch points where potential attack surfaces are there, where tampering or can be done. So in each area, we need to think about the cyber security. Okay, so network area, even automotive, some cloud security we need to introduce. So inside the network also we need to take care about cyber security. The cloud, where the because in nowadays, for example, in mobile you have auto updates, right? Like you get some message to update, get the your mobile updated. Similar way in vehicles also, like now there are the technology where the controller from one system you can update the controller inside the vehicle, which is called OTA, FOTA, flashing over the air, that technology. So that flashing, like whatever the software we need to flash, that has to put in cloud. From cloud, it is being connected to the vehicles. Then flashing is there. So cloud side also we need to take care about the protection, and of course inside the vehicle also we need to take care about the protection, say cyber security protections. So main objective is that, like, it's not only the vehicle side which we need as an automotive or a car maker need to take care about it, but at the outside also vehicle, for example, network side also, cloud side also, and inside the vehicle also, every aspect. So automotive maker, like a car maker or even a controller maker, has to take care about that aspect. Okay. So every area there is a cyber security protection has to be done inside the controller. So if there is, because after, like, there are complete testing based on cyber security attacks. Okay. So if any point controller get failed, so that controller cannot, we cannot use in the vehicle. Similar way, vehicle itself, at vehicle level there is a testing over the cyber security. If vehicle level is failed, then definitely then that vehicle cannot used in the mass production. So there are different level of testing is being done at component level, at system level, at the complete vehicle level, to ensure that our car is prone to and safe to the cybersecurity threats. Now comes to the, I hope only PPT is visible to you, right? Or this window is also there?
Yes, sir. PPT is only visible.
Okay, great. So what is the cybersecurity? Now we talk about cybersecurity touch points. Okay, potential touch point. Now I will cover some, but I hope this is not boring, right? Is it interesting or boring? No answer. Okay, anyway. So now, like in vehicle side, for example, if you, there's a V cycle. Okay, V cycle, usually every vehicle development or every component development is done according to the V cycle. So left side of V cycle is the, for example, activities, and right side of the vehicle is the testing activity for these activity. For example, first there is a cyber security goals and safety and normal function. So first step is designing function. Okay. When I'm designing, then that function I need to design according to function safety goals. I need to define what are the goal of this component or function related to function safety. Similarly, I need to define the function, how it is, what are the goals in terms of cyber security. So safety goals, cyber security goals is defined, and accordingly design of function is designed. Okay, decided. Similar way, function I decided, now comes to the architecture. So I need to design the architecture. Okay. Then if you go right side, so there is a function validity and there is a validity of safety goals of that function, and there is a validity of security goals of that function. Similarly, if again I come down architecture level, okay, here I define only function level. Okay, so function, for example, AC system is there. So AC system, there is a function to actuate condense compressor. This is one function. Okay, so that covers in this design of function. But cooling is the one complete architecture, which is a combination of some inputs also and combination of some outputs also, like actuator also and signals also, inputs, say like manual or some digital inputs. So that is the architecture design. So for architecture itself, like there are some many interfaces. So I need to define function safety goals for that architecture. Similarly, I need to define the security goals. And if you go right side, then we need to define the verify that architecture, verify safety concept, verify the security concept. If there are some issues, again redesign. So this is the V cycle. Like I verify, one side I design, other side I verify. Then if issues, then again redesign, then again re-verify. So like that, this cycle is there. Once I decide this architecture, then I design the system, HVAC system. Okay, complete AC system. So that system also have some system safety concept and system security concept. And similarly, I need to verify that design as well as that safety concept of system and security concept. Then it comes to the design of component of hardware and software, then again verify. So automaker, every car maker or every component controller maker has to go through this complete cycle. And it is not for 1 day job or 2 days job, it's a year's job. Any idea like how many, for example, if Maruti is launching Maruti launched, for example, Artiga. Okay. So what do you think if 2027 they will be launching one Artiga new variant or new vehicle. So when they start their product, I mean, designing, any idea? Any guess?
2024.
3 years. Okay. Okay. Near to that. But usually nowadays this development cycle is being reduced because of automation. But usually if any car which will be launched in 2026 or 27, the 26 car which will be launched, its design must have started in 21. Okay. So this all activities started in 2021. Okay. So then there is a design phase, there is some PP stage, pre-production, then there is a mass production stage, then there is a pilot stage, then there is a SOP. So almost each stage has a time period of 6 months to 1 year. So it takes, there's five stages. So it takes almost 5 years to launch any vehicle in the, like, I mean, whether it is in globe or in India. So it almost take 5 to 6 years for the development. So during this all, it take care about all these function safety and cyber security requirements. So these are the regulations which are there in cyber security. So basically, as I told you, safety point of view, there is ISO 2626 regulation and there is ISO 21448. And cyber security point of view, there is a UNR 155 and UNR 156 regulation is there. And in network side also, like overall network side, there these are the regulations. And overall quality management system, there is ISO, which is ISO 16949 is there. And if I talk about a time period, in terms of time period, in global, yet mainly whatever the regulation comes, it starts from Europe. Okay. So cyber security regulation like R155, that was in picture in Feb 2020 in US, yeah, Europe, and it was published in 21. So whatever the cars which are there in the US or Europe, they are compliant to R115 related to cyber security. And ISO, then it R155 was transferred to ISO. So this ISO means like its reach is expanded to other countries also. And in 21 it was published. Then in case of it was made mandatory for new vehicles by 2020 22. And I hope my screen is visible.
Yes, sir.
Okay. And in 2023, India side also, there is a regulation, ARI is there, agency, which published AIS, this is AIS is related to automotive Indian standards. So 189 it drafted, but I think it will be mandatory for new vehicles in 2027 and 28 onwards for all vehicles. Like this, this is a roadmap for the regulation implementation. for the cyber security in globe as well as in India. Uh, Now, this is complete history only. For example, as I already told, like there's UN Regulation 155 cyber security. So there are two regulations, safety and security, but both regulations required some four measures to be implemented, like managing vehicle cyber security risk and securing vehicle by design to mitigate those risks and protecting the responsibility incidences also in the vehicle fleet and providing some safe and secure software updates. As I told you, there is a FOTA, OTA, over the air caching. So that has to be protected. And for that, like from device management system, there is a security. From cloud point of view, there is security. Then in embedded system also, there is a security. This is again complete regulations. For example, black part is the regulations or laws. Uh, this light blue is related to standards and dark blue is related to best practices. But in any case, standards has to comply. Any vehicle has to comply with the standard. Okay. So these are the different safety and security laws which are there. Actually, these left side there are many agencies, automotive agencies. So these agencies has made these regulations, and many like ISO is on globe. There are Indian ASI. Similarly, different country have different regulation, but more or less every country has to comply with ISO. Okay. So this is the like ISO complete introduction. This is complete cybersecurity management system. So what it does is like if you see there are different total almost more than 15 areas where we need to define cybersecurity goals and we need to design. So if I start with the like there are general consideration, there are organization level cybersecurity goals, and project level there are cybersecurity goals and management. Then these are distributed activities inside the company, and some continuous like improvements are there which are related to cybersecurity. Then inside the project, like concept level, we need to define cybersecurity goals and concept, and during concept level, and then the product development phase also, and after development also, we need to define the cybersecurity goals and design accordingly. And there are some threat analysis or risk analysis methods. Different type of methods are there, and these all functions are categorized in different ABC category. And this is a approval process, how approval is being done in cybersecurity management system. So as I told you, there is a ISO, this UNEC regulation R155 or 156. So basically what any vehicle which will be launched in outside the, I mean, company, so that vehicle has to undergo through the approval authority to get these cybersecurity approvals. So these are the few approval authorities, like PUV is one company which used to authorized by this UNEC, and there is a DECRA also. There is an agency which approve cybersecurity compliance. So what exactly how it goes? So first, there are the tier 1, tier 2, tier 3 suppliers. Okay. Basically, tier 1, for example, OEM is there. That is the original equipment maker. OEM is car maker. Okay. Tier 1 is system supplier. For example, HVAC system. So HVAC system, that is a AC system, heating and ventilating system. So that system is being designed by the Subros. For example, Subros is a tier 1 company for AC. So inside HVAC, there is a compressor, there is a blower motor, there is a fan, there is a controller. So for example, controller is being designed by Denso. Blower motor is designed by Denso. Compressor is designed by some other supplier. So there is a component suppliers. So Denso is the tier 2 supplier for that AC system, HVAC. Similarly, now inside the controller, I had a microcontrollers. Okay. So that microcontrollers, maybe Denso is purchasing from Infineon, maybe purchasing from some other makers. For example, there is a NXP. So these are the microcontroller suppliers. So these are called tier 2, tier 3 suppliers. So tier 3 supplier also for microcontroller, they have defined cybersecurity requirements. So they need to, for microcontroller, also has to comply with the cybersecurity goals. Similarly, they will like make testing, they will design and make the testing, then they will generate the report, then they will submit this report to tier 2. So tier 2 is, for example, Denso. So Denso also again test, need to test at the component level. They also need to get certified. Then they need to supply the report to tier 1 Subros. Then Subros also at the system level, they need to test and they also need to make one report. Okay. So that report is being get it done by TUV. So every level they need to make sure that their component or their part or their responsible system has to undergo through the cybersecurity testing. Then this testing they share to car maker Maruti or other car maker. Then car maker also has to go for the type approval for the car. Okay, at design stage. So they get the approval at the vehicle level. Then only they get the approval. Then only we it is certified. Okay, this vehicle can go for the mass production. So this is how approval process goes for the cybersecurity management system. So every level cybersecurity approval has to be there. So at tied sub-component level, component level, system level, then the vehicle level. Okay. So this is again same sharing. For example, at vehicle level, at component level, they need to get it cyber security and safety. Okay, approval. So these are some security implementation in the vehicle security, some features in automotive. Okay, so like I hope till this it's comfortable, not so complex.
Yes, sir.
Okay, really? Okay. Anyway, so till now what we have covered? We have covered electronification. We have covered like what are the, for example, due to electronification, what are the challenges? Then we covered what are the safety and security differences are there. And then we covered what are the regulations for safety and what are the regulations for security. Now we are going more deeper to that safety and security part. So we are going more deeper to the security. Okay. So in security, like at tier 2 level, there are L1, L2, L3 levels are there. Okay. Accordingly, the component is classified class case A, case B, or case C type of component. So these are the elements in cybersecurity. For example, there is a access related security. This is the diagnostic security, flashing security. Then hardware level also there is a security. For example, and there is a further message authentication security when we are transmitting, then message itself is getting secured. And there is a secure boot. For example, now I'm flashing some software. So that software is being flashed by the bootloader. Bootloader is a software which is does the complete flashing like inside a vehicle. So that bootloader has to be make secure, and there is a dual wing concept how redundancy need to ensure. For example, if one system fail, at least second system should work. So that is the redundancy. That is the two-wing theory. So these are the different kind of security elements. Okay, and based upon that, because everything security or safety, whatever it is, but it involves the cost. So based upon the like future strategies, based upon the vehicle, for example, if Alto, I cannot give 100% security. Okay, so there are some feature level cost is involved. So based upon that only levels are defined L1, L2, and L3. So highest level is L3 level security, where every these elements whichever are listed, almost I think 8 elements are there. So every element is like there is a complete implementation for every element inside the controller. For example, if I am developing ABS controller, so ABS inside ABS controller, I need to make sure these every element has to be present. Okay. So this is the kind of features which are there in automotive. So I will not touch too much. I will touch only like what is a flashing. Okay. So do you know what is a flashing? Flashing basically, actually, I have a controller. Okay. So there are different inside controller. For example, human body has different body parts. Similarly, controller has a in there are different hardware or components. But software point of view also there are components inside it. One is bootloader. Main is the application software. That is the logic part of software. Similar way, there is a diagnostic software which deals with the diagnostic part, and there is a fail-safe software which deals with the fail-safe mechanism, and there is a communication module which deals with the communication between or outside or inside the controller. So there are different modules. Each module or each part component in software point of view has a different function. So main function is the application software. So that application or logic part, like how controller will behave. For example, if I need to make a AC temperature cooler, okay, 23 degree. So this is the user input. So what I need to do is inside controller, user will get the input. Then I want, okay, it air should come only on face, not on my foot. So that time, this inputs comes to the user, I mean controller. Controller takes this input, process it, and actuate accordingly to the compressor. Like compressor uh, pressure is controlled, then accordingly temperature is controlled. So this is complete logic that is taken care by the logic software. So this logic software has to flash inside the controller. For example, like okay, there is some field failure, so due to which I have to change my logic. Okay, now I need to flash it inside the vehicles which are there inside the outside, I mean factory. So mass production has already been done. So that part, there is a one component bootloader which allow all these software to flash inside the controller. So that bootloader, that is called a security flashing. So this bootloader ensure like, for example, anyone cannot flash that software. So it has to be some digital signature verification to confirm the authenticity of program parts. Okay. Similarly, hardware level also, like there is a complete what we call hardware securities are there, which is there inside the controller. So these are all level of security elements which are there. Then comes to the bootloader. So inside bootloader, like there is a seed key mechanism. Okay. So basically, seed key also like there are different levels. For example, data length is for example, basic level is a 4 byte. This is public algorithm is inside it there, which is with the OEM, first supplier, second supplier, and tool maker. So this is the level of security. which is there, like it is a low level of security, only 4. So this seed key, I mean, potential attack, it can be there for this seed key, but there is a level, at least it will not allow anybody to access the bootloader. So similar way, there is a further enhanced security access. This is 8 byte. So private key is there. So in case of first case, previous case, 4 byte, like there are combination of total 42 combination. Algorithm is XOR algorithm is there, or shift algorithm, but there are 42 combination billions. So that means at least 42 time billions. It whenever I'm generating new seed, it will generate new key 42 billion different time. So hacking time is 1 minute. But when I talk about 8 byte, normally nowadays every controller has a 8 byte seed key. So that is using algorithm of modular or additional or rotational XOR and shift combination of all these different mathematical operations are there, and it has a combination of 1800 trillion. So hacking time, it will take 5000 years to hack this seed key. So that is the level of security which is there to unlock. So basically, like uh, how it works. For example, we have algorithm in a tool. So this I need to transmit in the inside the controller. So this algorithm will check that this is the input seed, output key. So seed and key should match. Then only it any software can get flashed inside the ECU. So this is how it works. Then there is a like a further level one AES. This is a standard 128 algorithm. Okay. So that is the one regulation which here you have a private key with OEM. Similar way here also you have a this is with the OEM only. The like car maker only have this algorithm. Nobody can take this from OEM. And there's some random generator TRNG is there by HSM technology. So level of security is very high in this case. Here also like 32 bytes, it's AES. So almost combinations are impossible combination. Any combination, I mean, any time, for example, whenever I'm generating key, there is a like 101% possibility different key will be generated second time. So it's almost hacking possibility is impossible for such keys. So such keys are being used inside the controllers. Then this is a kind of a like mechanism how secure flashing is there. So secure flashing, as I told you, like inside it, for example, this data I want to flash inside the controller. So what it does, first this logic part is a hash key. This hash key value is there, that private key is generated. Then this data is being signed and the signature is generated. Then there is a signed data is there. Then signed data I want to put in the controller. So this data here, it is encrypted. Then it is decrypted. So there is also inside the controller is an algorithm. So it matches, then only it is decrypted. Then it hash values or these computed hash values are compared. Then only EC allow the controller to flash the software. So this is the hardware level security. Inside the microcontroller also there are many security levels which are there. So like there are text access JTAG points are there. For example, inside the controller when I'm developing, there are some points which I can access, which is through the JTAG one port are there. Here I can get the information about what is the communication going on inside the controller. So those JTAG ports are also logged after mass production, so permanently. So you cannot see those points, okay, inside the controller. So similar way, packaging of ICs are such a way that it you cannot expose pins are not exposed. Nobody can access pin. Sometimes by accessing some voltage level, I can get some information. So that packaging of ICs are such a way that you cannot access the pins. So there are some kind of ICs like this LFF BGA IC, which has a packaging, you cannot access the pins. Okay. Similarly, hardware component connectors are PCB are included in any connector. So these are designed in such a way that PCB itself connectors are not exposed. And in controller level, there is a HSM hardware security modules inside the control microcontroller level. And similarly, there are secure software architecture are there, which are there for hardware security module, which prevent hardware from hacking. So these are the example of some microcontroller which have these kind of hardware security modules are there. So Infinite microcontrollers have hardware security modules, and it has some random number generation generator also, which allow like have a complete security inside the microcontroller level. So in, for example, one controller to another controller, there are different messages are being transferred. These messages are also being secured by this CMAC technology. So again, secure bootloader itself, as I told, there is a security level inside the bootloader also. So there is a bank flashing over the air. So here again, bootloader itself is secured. So this is all the implementation aspect at the vehicle side. Okay. So I hope uh, you get to know some exposure about the vehicle side, whatever the technology or whatever the cybersecurity requirements. So I know like it's very complex topic. So at least 2% you might have get it, but if you go in deep, you will find many interesting areas. So with this, I end my presentation. If you have any questions, so I think we have 15 minutes, so we can have Q&A.
So, what are the cybersecurity challenges in these type of vehicles?
Cybersecurity challenges, as I told you, like see at every level there are the cybersecurity threats, because as I told you, then when there is electronification inside the vehicle, so definitely there is a communication between the different controllers. Then there are the different challenges at the component level, at the system level, and at the environment level. Okay. So at every level, there are many challenges as I defined touch points. So every these are the major threats which are there, like some physical threats are there, the unintentional damage or some failures or malfunctions are there. So many like every part, system level, component level, network level, environment level, there are the challenges. So to mitigate those challenges, my design of my controller has to be compliance to these regulations, security and cyber security, safety. Okay.
Okay, so then-
Any other question?
So feedback form has been sent in the group, and if you any of the participants has any query, you may ask. Puran sir, I think your session was itself self-sufficient.
Okay.
Participants do not have any query, so I personally wants to thank you
Okay. Thank
for
you very
this
much.
session and sparing your time. Right, over
Yeah.
to you, Jagriti.
Yes, ma'am.
Jagriti.
Yes, ma'am. Yes, ma'am. Okay, sir. So, on behalf of the organizing team, I extend my sincere thanks to you for delivering such a wonderful and informative session. We truly appreciate your valuable insights and the knowledge you shared with us today.
Yeah.
Thank you
Sure.
so much, sir. And we truly appreciate And thanks to all the participants also for their active participation and valuable presence in today's session. We appreciate your enthusiasm and engagement, and we look forward to your continued participation. Kindly ensure to join us on time tomorrow also for the next session as per the schedule. And thank you once
And
again.
I want to add one thing over here, that all the participants kindly fill the feedback form, that then this feedback form will be counted as your attendance. So
Attendance.
all of you, it is mandatory for all to fill this feedback form for all the sessions. Okay, thank you all.
Okay. Thank you very
Thank you so
much. Thank you very much. Okay.
Okay, thank you.
Thank you, sir.